Hi, today we will be talking about environment diagrams using this example that you see here on the left side of your screen. An environment diagram is just a way to document what's happening in memory as you go through different stages of a program. Here we have the stack on the left and the heap on the right, so let's just jump right in. Now, the first thing that we always need on the stack is our global frame. This contains everything that's accessible at any point during the program. It also contains anything that's defined outside of the main function. So the first thing that we see when we look at our program is this class Hurricane, so we can add that to our global frame. Since this is a class, we just draw an arrow to a box that says class on the heap to mark that there is something being stored in memory on the heap, but what exactly that is, we don't have to worry about. The next thing that we see as we run out our program is this new variable Michael, which is a hurricane. So we add our variable Michael to the stack, and then since it's also being instantiated here as a new hurricane, we can go ahead and create a new hurricane in our heap space in memory and fill it out with the default values that a hurricane has. So a hurricane has the properties of a category, which we'll abbreviate here as cat, a name, and states affected, which we'll abbreviate here as SA. Default category is 0, default name is an empty string, and the default states affected is an empty string array, so we'll include that here on the heap. So this is sort of what a default hurricane will always look like when we create a new hurricane object, and Michael points to this particular new hurricane object in memory. On line 8 of our program, we see that the name property for Michael is reassigned to the string Michael, so we'll change that here on the heap. Similarly, the category will be changed to be a 4, and the states affected property of Michael will be reassigned to be this new array full of the strings that we see listed out on that line of the program. The next thing that we're going to define in our program, still in this global frame, is the main function. Now in our diagrams, we don't worry so much about what exactly a function looks like when it's stored on the heap. We just point an arrow to this little box with an fn in it, and that means that we're creating a new function here. That means that we're storing what this function does in memory. We also have the functions genNames and getCategory. Cool, so before any function is even called, this is what our program looks like. It's sort of set up where functions are stored in memory, and we have some global variables, like this hurricane object, that are also stored in memory already. Now there on line 40 at the very bottom of our program, we see the first call, a call to main. So we're going to go ahead and get our main frame set up here, which will hold all of the variables and information that we need to know when we're inside the main function. Now the first thing that we see is creating a new variable in this main function called Michael. Now, even though this has the exact same name as something that we already have on our global frame, this is a very different kind of Michael. This one is sort of scoped inside of the main function. It's accessible in that main frame. So this Michael variable is initialized as a new hurricane. So we're going to go ahead and set up a new hurricane object on our heap that has all of the default properties of a new hurricane. So we've got a category of 0, an empty string name, and an empty string array as the states affected. Oop. Cool. On the next line of our program, we see that we're going to be assigning a new value to the states affected property of this Michael variable. And we're doing this by giving it whatever call to genNames returns. So we're going to need a new frame on our stack that's the genNames frame. Every time you call a new function, you need a new frame on the stack. This sort of lets you know where you currently are in your program and how your variables are scoped. Now the very first thing that gets created in genNames is a states affected variable, which we know is a string array, which originally is an empty array. What we're going to do now is a little bit funky. We're using a for loop inside of this genNames function. Now, a for loop or any other block of code can have new variables created inside of it that are scoped to exist only within that block of code. So what we're going to do is create sort of a mini frame within this frame, which will hold the variables that are created and used only within that for loop. We're basically drawing this just to know that our I counter only exists within that block of code where the for loop runs, and after the for loop is done, this whole little section and our I variable will no longer be accessible and will be erased and won't really exist anymore. So our I starts at 1, we just put the actual value in there. So now we're comparing the value of I to Michael.statesAffected.length. But in this genNames frame, we don't see any Michael variable. So where are we going to look? You might think, oh, let's just pop up one to the main frame. But that's not what you want to do in this case, because genNames doesn't actually know any of the information that exists in main. What genNames can see, though, is a global variable. And so we look in our global frame and we do see, okay, there's a Michael variable here, and it has a states affected array. So we can look at that, Michael.statesAffected, this array, .length, which would be 4. Since 1 is less than 4, we go into that for loop. Now we're looking at this states affected variable that exists in the genNames frame, and we are appending the ith value of the Michael.statesAffected array onto the end of this string array. So since I is 1, we'll put the first value, or like the 1th value, of this array onto the end of our states-affected array. With an I value of 2 and an I value of 3, we're going to sort of continue in the same fashion. But when I becomes 4, we no longer meet the criteria to enter into that for loop, and so this entire for mini frame disappears, and we're done with that block of code. So we're wrapping up our function called a genNames, and this is the state of our program as we hit that line 30, where we're supposed to take a pause and kind of take stock of where we are and answer some questions. So question 1.1 asks, from genNames frame, use name resolution to look up the name Michael.statesAffected. What frame is it found in? So we're currently in this genNames frame, right? That's where we've been working for the last little bit, building up this array. When we look and try and find the information Michael.statesAffected, we're looking to see where we're going to find that variable Michael. Now, genNames has no accessibility, no visibility into the main function. The only way that we could have some information from main in this genNames frame is if during our call to genNames from the main function, we had also included some information from main as an argument. But since genNames doesn't have any parameters, there was no way to get information from main to genNames. So we look at the variables that genNames has. There's no Michael in here. And then we go up a level to where genNames exists and see, okay, is there another Michael up here? There is. So that's the Michael that we were using to identify that Michael.statesAffected property. So the answer to this question is that the Michael.statesAffected name is found in the globals frame. For question 1.2, they're asking, from mains frame, use name resolution to look up the name statesAffected. What frame is it found in? So from mains frame here, at this state in the program, we don't see a variable called statesAffected in here. We can look here, and we can also look to any frame that main exists within. So that means that here we can also look at the globals frame. But when we look through globals, we also don't see that name statesAffected. So for this question, we would just say that it's undefined, because we don't have the variable statesAffected here available in main, or in another frame of which main is a part. Alright, question 1.3. From genNames frame, use name resolution to look up the name statesAffected. What frame is it found in? So here in genNames, we look and we say, where can we find a variable with the name statesAffected? And look, it's right there within that frame. So the answer to this question is that it's simply found in the genNames frame where we were looking for it originally. Cool, so let's continue through the rest of our program. So at line 30, we're returning this array right here, the statesAffected array, and this genNames function is going to be over. And what that means is that this whole thing, this whole frame is going to pop off of the stack and kind of disappear. And all that we're left with is this piece that we were going to return. Now, where does this go? Because right now it doesn't seem to be attached to anything in memory. Well, remember back at line 14, we were assigning the result of calling genNames to Michael.statesAffected. So we look at our Michael from within the main frame and its statesAffected property. And we simply reassign that pointer to the array that we just returned from our genNames function call. So instead of pointing to this empty string array, the statesAffected property of this Michael variable now points to this array that we just returned. This empty string array that was created when we made the original hurricane object here, this still exists in memory, but now we just don't have any references to it. So eventually, in languages like Java, it will just get garbage collected and disappear. Same deal with this string array up here. If there are things stored in memory that aren't referred to by anything, you can't get to them, and so eventually they'll just be cleaned up and taken away. They're effectively already gone since you can't access them anymore, but a language like Java will take care of actually removing them from memory eventually for you. It's called garbage collection. Alright, on to line 15 of this program. Now we're creating another variable in this main frame, and it's called Florence. Florence is another new hurricane, so just like we did with both Michaels so far, we're going to create a new hurricane object on the heap that has all of the default values of a new hurricane object. Cool. So now what we're looking to do is reassign the value of Florence.category with whatever value getCategory of Florence.name returns. So since we're calling a new function, we need a new frame on our stack, and this time it is the getCategory frame. So this is an example where we're passing in some information as an argument to this function call. The information that we're passing is whatever the value of Florence.name is. So right now, Florence.name is just an empty string. That information is the name parameter of this call to getCategory. So just from passing in this empty string and having a parameter that asks for a string that's called name, we already have a variable named name that's storing an empty string in our getCategory frame. Now all that this getCategory function does is compares this information stored in its name variable to the string Michael, and if they match, it returns 4, Otherwise, it returns 1. In this case, this empty string is not equivalent to the string Michael, so we're going to return a 1. Now, just like when GenNames finished and the frame popped off the stack, we're going to be popping off this getCategory frame from the stack, and all the information here will disappear, and we'll just keep in mind that 1 that we're returning from this function call. So that entire phrase, getCategory of Florence.name, evaluates to be the value that is returned from that function call. So Florence.category is now going to be assigned the value of 1. On to line 17. I didn't quite make my main frame big enough, so I'm just erasing this, giving myself a little bit more room, because now we have a new variable to add to our main frame, the hurricanes variable. Now we're initializing hurricanes with a hurricane array, which is an empty array, so we can go ahead and draw that out in our memory. Even though this array doesn't have any information in it yet, just the fact that this array exists in memory is something that we want to mark down in our heap. So the next line of code is assigning the first element in our hurricanes array, or the 0th element really. Now it says we're going to assign it to be Michael. We have a Michael here in our main frame, but what's really, really important to remember is that we are not ever going to draw an arrow pointing to something on the stack. Instead, we can point this arrow of the 0th element of the hurricane array to be the same information that Michael is pointing to. So it's going to get a little wonky with the arrows here. I'm going to switch colors. And this is a little tricky because we're getting into spaghetti territory. We'll draw an arrow that points to that exact same information that the Michael variable is referring to. Same deal goes for the next line of code, where we're assigning the value of the first element in the hurricanes array to be the same information that the Florence variable holds. But here our arrow is a little bit shorter and less squiggly. So this is the state of our program as we reach line 19. In lines 20 and 21, we do a similar thing to what we did before with the for loop that we encountered earlier, where you create this mini frame within your frame that contains your I variable, since your I variable is scoped to only exist inside of that for loop block. Now each turn of the for loop here is going to print out the category of each hurricane element of this array. So for element 0, which refers to this hurricane, the category is 0. And once we increment I, in the next turn of our for loop, we're looking at the first element of this hurricane array, which points to this hurricane object here. The category there is 1. We'll print out a 1. Incrementing I to 2 leads us to the realization that hurricanes.length is 2, and 2 is not less than 2. We're done with our for loop. We'll erase this mini frame and carry on with our program. So what happens now? We're done with our main function, and so all of this information that we've created and kind of kept track of in the main frame is going to be popped off the stack, and all the references and variables will disappear. Now technically all of this stuff still exists in memory, but since we have no more references to get to any of it, eventually it will all be garbage collected and will disappear forever. That leaves us with only our global frame and the information that's referred to from there. Thanks for watching. This has been our video on environment diagrams. Got questions, fun facts, things you want to know more about? Leave it in the comments below and we'll get back to you.